clicked on recording. And okay, it asked me to ask you for permission to record. So
My computer's acting bulky, but it's recording now. Thanks.
Okay. Yeah, we forgot all about it. Well, nobody needs to hear me anyway. That was cynical humor there. Okay, now this is the newer version of the NexRad radar. Personally, I don't know, Bob, you think of it. I don't like this as much. I liked the earlier NexRad one. You had the possibility of being able to zoom in on it, and it's more detailed in closer in. This is very detailed for the entire country, but you can't get like right down to neighborhood size, which you could with the preceding NexRad radar. I find that a little frustrating, but this one will show you, like right here, that's a, not quite a derecho, but a storm front. It's got heavy rains in it. And here we have some lighter rain in our area, and right here over Oshkosh. And up in Portland, it's raining. Of course, it always rains in Portland. That's another joke. Now, satellites. One of the greatest tools that has come along in the past, 70 years is weather satellites. About the second or third thing they did after they started launching satellites was put cameras on them to take pictures of weather. There are two basic kinds. The geostationary satellites, which they are high enough that they match the rotation of the Earth. So it seems like they are over a fixed point on the planet. They're moving. They have to move to stay in orbit, but they are in this. They remain over a fixed point on the over the equator, about 36,000 kilometers up. Then there are also polar orbiting satellites. These are set up so that their orbits are at the same plane relative to the sun. There's one set up for the morning hours and one set up for the afternoon hours. They orbit about 850 kilometers up, so it's slower, about one orbit every 2 or 3 hours. So the geostationary satellites, it's the GOES, Geostationary Operational Environmental Satellite. They're the only ones that are in geostationary. Well, check that. The Metrosat for the European Union is the other ones. Our Weather Bureau mostly goes with the GOES, pardon the pun. They're at 75 degrees west longitude and 135 degrees west longitude. And you figure the center of the country is about 90 degrees west longitude. You can see that we're sort of bracketed, one over the East Coast, one over the West Coast. And one of the nice things about orbiting stuff is you can park things up there like a satellite. And then when should you need it, you just tell it to fire its thrusters and change its orbit and get into the proper position. Scary, isn't it? The European Union has what they call the Meteosats, which are for European weather. So they're over farther east of us over Europe. The polar orbiting satellites include the NOAA satellites, defense satellites, DMSPs, and again, the European Union METOP satellite. And our Weather Bureau gets data from all of those. Now, different satellites, they have different instruments, they record different things. This is the GOES East satellite. Again, it's in geosynchronous orbit. You see how high up that is, 33,000 kilometers above the Lake Michigan there. It's using sunlight reflected from clouds. The DMSP satellite is so powerful and sneaky that it can actually use moonlight. You can't really tell how high those clouds are because you're right above them and a good distance away, but just good weatherman probably has a feel for it. The infrared, this is, uses, you want to say something, Bob?
Yeah, could you go back one?
Certainly can.
Good weatherman. I heard you say good weatherman. So one of the things that is displayed is how bright, see that top line there, uses sunlight reflected from clouds. So for a weatherman, if there's a bright white, that's a sign of a very high cloud, and also can be an indication that there's some severe weather going on there, because those are going to be, you know, up at the 50,000 foot level. So just like Chaz said, the brighter it is, the taller the cloud.
Oh, okay. I would have thought, Bob, that the brighter it is, the denser the cloud is. But you're the expert, so okay. And moving along, infrared is heat. So this satellite is looking at the infrared radiation emitted by the clouds and by the ground. So colder clouds are higher up. The higher in the air you go, the cooler it gets. Warmer clouds are lower down and doesn't show really low clouds very well. And it's artificially colored to give contrast and give an eyeball readout of what the temperature is. So blue is colder and yellow and reds are warm. And there's a scale, a scale down here at the bottom of the picture that tells you the color versus the temperature. Water vapor, of course, we've learned in this class already that water vapor is what really drives the weather. This is the water vapor data. It shows the total amount of water vapor in the atmosphere from the top all the way to the ground. It can be used for identifying air masses and locating storms. And it shows the circulation patterns. This isn't clouds exactly. The water vapor is what clouds are made up of. But it's showing you the water that's in the air. And that will give you an idea of what the weather is going to do. It's the color scale is driest on the left. Again, this is the scale down here at the bottom. Driest on the left, wettest on the right. So the magenta and blue are very wet, and the white is kind of middling. One thing I wanted to mention, and I haven't had a chance to, is clouds are not an object. It isn't a thing. A cloud is an area of the atmosphere where conditions of temperature and humidity and pressure cause water vapor to condense. They aren't a thing. And Bob is saying, what? Okay, moving along. Upper air analysis charts. We were talking about, a week ago? They're made twice a day at different pressure levels. And the 500 millibar chart is the most useful. And remember, it has the ISO height bars on it. It shows warm and cold advection, which affects the surface activity. Convergence and divergence affects the lows and the highs. The ISO heights are spaced at 6 decameters, and the isotherms are in spacings of 2 degrees. Jet stream shows up at 300. So here's the 500 millibar analysis chart for the same day. Now, notice again, we have not a really solid low, but a sort of low pressure circulation going on here. Under this is where that low is that was causing the weather in our part of the country, except for you guys in Florida. Us people in Chicago area, let me qualify that. And then you've got this ridge through here, which is where all the high pressure was. Then we've got a little trough running along the west coast of the United States, and we had some lows and storms in that. Here's the 300 millibar analysis chart. Yeah, that's got a lot of information. Again, you've got a ridge in the middle of which is a high pressure. a sort of low pressure in there, but mostly what we're looking at is this green line is the jet stream. That is what pushes the weather from west to east across our country. If it's up north, it pushes the weather north of us. If it's way down south, it pushes it south of us. The 850 millibar chart, again, we've got a low pressure here, a ridge in the middle. And yeah, this is a lot of information, which makes sense to weather people who know what they're doing with it. For us, people on the ground, it really doesn't matter that much, but it's nice to know that it exists. Now, sources of forecasts. Where do you get your weather from? There's different kinds of forecasts. The persistence, trend, analog, and climatological. We'll talk about them. Other models, chaos theory on accuracy, and the forecast at the surface. Marine forecasts and surface prognoses. Where to find a forecast for auxiliary operations. This is what you came for. Okay, so prior to numerical forecasting, other methods were used. There are, what, 3 different basic kinds. Your book goes into this a little bit. Persistence forecasting assumes no change day to day. So when the weather doesn't change much, you can use this. So like weather in San Diego doesn't change much. Weather in Baja California doesn't change much. Weather in Key West, Florida doesn't change a lot from day to day, although it can. Unless you get all romantic and think about how nice it would be to be in a place that had persistence forecasting, I can point out that in the Arctic and Antarctic, they have persistence forecasting too. You don't want to go there. Trendcasting assumes the movement of systems is linear. So what happened to the weather last week is what's going to happen this week and what's going to happen next week. The lows come out of the southwest and move to the northeast. Sometimes they go north, sometimes they go south. It's most useful for short-range forecasting of thunderstorms, supercells, tornadoes, hurricanes. Analog forecasting depends on comparison with similar situations in the past. So a really good forecaster looks at his weather map, looks at his upper level maps, says, this is what it was like 2 weeks ago, so we can expect to see the same weather tomorrow. It depends on the experience of the forecaster, and we've got good forecasters here, don't we? And it's used to adjust the short-range numerical forecasts. Numerical forecasting is comparatively new. This is where you take the information from a bunch of different stations at a bunch of different heights and locations in a 3D grid and put it into a computer and run it for short time steps and repeat it and repeat it and repeat it until you get it doing basically the same thing every time. So that's as accurate as it's going to get. It depends on the precision and accuracy of the observations, the grid spacing. The more spaced out they are, the less accurate it will be, but the faster it will run because there's less information that has to be processed. Now, you may have heard of chaos theory as applied to weather. The classic example is the joke that a butterfly flapping its wings in Brazil, or a butterfly flying left of a tree in the Brazilian rainforest instead of to the right of the tree makes it rain in Boston. That isn't really the case. That's how the very early mathematicians were trying to describe chaos theory. And that book I had showed you last week, Isaac Storm, goes into this a little bit. What it is that if you start with the same data and advance it, in one situation, you'll get rain in Chicago. Another situation, starting from the same data, you won't get rain. And there's no observable difference between those two initial situations. So the joke is that something really, really small, like a butterfly flapping its wings, caused the difference that made the difference between rain and no rain. But so much is going on in the atmosphere that you can't really say that. It just is. Sometimes it does, sometimes it doesn't. And it's the driving force of the weather. So there it is, 3D grid. The more of those you've got, the more accurate it is, but the faster or the slower the computer will run trying to handle all that data. This is a very confusing diagram, which is purports to show information coming in from all these different sources, processed for quality control, errors corrected, like it's not 200 degrees in the Arctic, so that can't be right. It goes to an analysis and then put input into the grid. Added to this, calculations are made, and there to the information, and the data comes out and is made into forecasts and put out to the public and to businesses and Coast Guard coxswains for them to decide whether or not to go out that day. Other numerical techniques are what's called ensemble forecasting. That's where the data is run through several different numerical models that are run on computers, and the inputs are slightly altered. The results are compared, and the closer they agree, the better the forecast is. So if you get, if you have a low in Texas and you run 3 days of data on it, and it always goes up the Appalachians and through New York City, it's good. If one model shows it going out through Florida and another model shows it going up through Chicago, the information is not as good and the forecast is dubious. Large scatter means that less trust should be put in the forecast. What happens is you wait 3 hours, run it again, and see if it's tightened up any. And then you run it another 3 hours and see if it's gotten any better. Model output statistics allow known problems with the model to be adjusted, is what that means. So for surface forecast charts are used. You can use this to figure out what's going to happen in the next 12 hours by observing the way the fronts lie, the isobars lie, and the way the weather is moving. So you go back 6 hours, see which way those lows are moving, and then you can figure out where they're going to be 12 hours farther on. Then you compare with a later analysis, and trying to see here. Okay, we still have these lows here, but they're moving out to the northeast, and you see that there's the main just east of Chicago. This is, if you read this block in the corner, it says 12-hour forecast of fronts, pressure, and weather, issued at about 2 p.m. Tuesday, December 16th, valid at midnight on Wednesday, December 17th. So that's 10 hours farther along. This is where the weatherman figured the weather was going to be 10 hours after he made his estimate.
Something happened to your mic, Jazz. I can't hear you very good.
Oh, I think I was leaning into the screen to read the little block there in the corner. So read it for yourselves, guys. Now, 24 and 48-hour forecasts are, the farther out you go, the less certain you are, just because, again, chaos theory and things can change. And there's one with some analysis. Quantitative precipitation Again, he's estimating based on where the lows and the fronts are, what the rain is going to be based on his knowledge and observation and his modeling. Now, marine forecasts are subtly different. Here, this is the middle of the Atlantic Ocean. It's a 12-hour wave direction and period forecast. The arrow shows which way the waves are moving. The color depicts the height of the wave. So I don't see a scale on here, but there will be a scale. Blue is probably lower waves and red are very high waves. And they will be moving the way the arrows show them going.
Can you see on the far right where the scale is, the lower right?
Oh, okay. It's under the member thing piece here. Yeah, I couldn't see it.
What are the units?
That's a really good question, Jim, and I don't know. Bob, do you know what the units for like wave height would be? Would they be meters or feet? I'm sure that it would tell you somewhere, but I'm not seeing it.
I'm contacting my friend Mr. Google just so I get it right. I'll call you in a second.
Okay, but that's a very good question, Jim. Just like with the chart, it really depends. If you go out thinking the waves are 2 feet high and it turns out they're 2 meters high, you're going to have more trouble. So I'm going to skip ahead. Okay, now, where to find all this stuff? So you're a coxswain or even a crew member. You can go to the Weather Prediction Center or the Ocean Weather Prediction Center, which doesn't a whole lot of good. Storm Prediction Center is going to be very helpful. National Hurricane Center is a lot of fun. Again, that doesn't a whole lot of good. It's more for you folks down in Florida. There are a lot of smartphone apps for weather. As I say, I really like, what I do is I go to NWS, National Weather Service, and enter Chicago, and they will give me an entire page of weather information. One I really want to bring up, I had Bob's the thing that I like to use, which is the hourly weather graph. You can enter your location in that, and that will tell you everything that is going to happen for the next 2 days in a graphical form. Temperature, humidity, rain, snow, winds, direction, and strength, and cloud cover. And because it's linear, you can see what's going to happen and what the trends are. So dear Amy showed me that a few years back, and I've used it ever since. Radar, there are several different apps to use on patrol. Like I say, I'd like one that really showed close in. You got to shop around and find one. If you find a weather page that you like and is giving you information that you can really use, bookmark it and keep going back to it.
Hey, Chad.
Yeah.
So it was in feet. It can be changed to meters, but it routinely will show up in feet, the wave heights on the 12-hour forecast. Feet.
The sun never sets on the Empire, except they went metric a few years ago. All right. Oh yeah, one more thing too is just for yucks and giggles. Some of these YouTube videos I watch about people sailing. Devos is one, Sailing Solianus is another one, and they will go to, on their chart plotting software, they can get wind information. And I believe it was Wind Tracker. I'm going to have to go and look and see which one it, but it was a lovely website that showed which way the winds are blowing and how hard anywhere in the world. And so, and for like up to 3 days in advance. So for motor sailors and especially for sailors, that is a great thing to have because you can look at it and see, you'll be out in the middle of Lake Michigan, which way the wind is going to be blowing and how hard. And so I bookmarked that myself for use. There is a Coast Guard app that has a lot of weather information on it. For whatever reason, I could never get it to run on any of my small portable electronics, but it's there. And if you go to NWS, National Weather Service, and hit any of those sites, you'll be good. Oh, one other thing is, Ruben, are you there? Jazz to Ruben, come in, Ruben. I can't tell because the little block is only. What I wanted was for, if Ruben was here, for him to turn on the radio he has and play the national weather rating, and I can't find him.
He's muted.
Oh, so he is on here someplace?
Yeah, I sent him a message.
Okay. I'm not seeing him anywhere.
You hear, Ruben?
I'm going to finish this up quickly because you've only. There we go.
Tuesday night, mostly cloudy. Lows in the lower 20s. Wednesday, partly sunny. Highs in the middle 30s.
Good enough?
Yeah. Okay, what you just heard there was WX4, which is the National Weather Service weather radio. Every VHF Marine radio has that, usually on a fast button. And you can get a verbal weather forecast for your location from that, off of your radio. Thank you very much, Ruben. One more sea story. I don't think I told this one, maybe I did. Our good friend Barry was out doing vessel safety checks at Wilmette, a few years back, and they had that radio on, and they could hear a front coming down because it kept changing and saying, you know, severe weather at Milwaukee, severe weather at Racine, and so forth. And they were telling people not to go out on the lake. And people were saying, what do you mean? It's clear blue sky. It's perfect. I'm going to go out on the lake. And sure enough, right on schedule, a storm front rolled in, dark clouds, high winds, and all of a sudden, all of the vessel examiners became traffic police, getting boaters out of the water as fast as possible, and then giving them vessel safety checks. Okay, summarizing. Finally, at the end, the surface analysis maps are produced every 3 hours in a variety of formats, showing information like radar, satellite data. Radar data from the next red Doppler radars shows motion towards or away, and it shows precipitation, wind, and turbulence. They're available for just one station at a time or whole country. They see precipitation, clouds, and turbulence. Satellite data is available from two different kinds of satellite, the geosynchronous orbit satellites. There are two different kinds. And then the polar sun synchronous satellites. There are three different kinds. Images are available in visible, infrared, a long wave and short wave, water vapor. Upper analysis maps are available every 12 hours at different elevations or different pressure elevations. They show ISO height, isotherms, and winds and constant winds. The 500 meg chart is best for tracking storms. The 300 for the jet stream. Forecasting methods include persistence, trend, analog, and numerical. Numerical forecasts are improved by ensemble forecasting, model output statistics, and forecast different types are of surface and upper air prognosis, quantitative precipitation forecast, the marine forecast, which is the one we're like, and a whole bunch of others. You have your pick. Go to NWS or just, I dare you to enter weather into your search engine and see what happens to you. Okay, Bob, these questions are the same questions that are in the chapter in back, but there are fewer of these. So I recommend going directly to the book and reading those questions. Bob, you with me? I don't know if Bob's there or not.
Sorry about that. Yeah, my computer's being bulky. I'm trying to display the questions for us. Could you do stop sharing on your display there?
I can. And there we are.
All right, nobody leave the room.
Excuse me, would anyone like to hear the Florida national weather?
Days 2 through 7,
Yeah.
Friday through Wednesday.
Yes?
A cold front will move across the area on Friday and will be preceded by showers and isolated thunderstorms. Much cooler temperatures will filter south across east central Florida behind the front overnight Friday into Saturday. The rip current risk will be moderate at area beaches again on Friday.
Can you hear it?
Boarding conditions will remain.
Yes, we can.
Friday through the weekend as winds increase and seas build. Spotter information statement. Spotter activation will not be needed tonight. The forecast for the Daytona Beach NOAA weather radar listening area. Tonight, partly cloudy late in the afternoon and toward sunset, and considerable cloudiness. Slight chance of thunderstorms before sunset. A slight chance of showers late in the afternoon and toward sunset. Then a slight chance of showers.
Thanks.
Okay.
Yeah.
I'm done.
So, yeah, the weather that was being displayed there, that they kept showing on those images that Chaz was sharing,
Yes.
that was a big storm that hit California with a lot of snow that piled up snow in the Sierra Nevadas, and they called it the storm of the decade. So I'm going to go ahead and ask questions. Adam, you want to take on number 1 there? Surface analysis are produced. Adam?
Every 3 hours. B.
Excellent. Trying to remember who said they were going to be here. Al, are you here? Alejandro? Number 2, Alex Carmichael. Weather radar data are available.
I forgot to unmute. D, all of the above.
All of the above, correct. Well done. Amanda McAllister, number 3, current weather radars are?
B, based on the Doppler effect.
Correct, yeah. Chaz hit that pretty hard. Good job. Number 4, weather satellites are Anita Lutkus.
D, both A and B. In
Both
low
A and
orbit.
B, good. Number Ann Brink, number 5, polar orbiting weather satellites.
Hey, go back to that last question.
Oh, who is that? Mike?
No, it's Jim Davey.
Go ahead, Jim. What do you got there?
The last question, whether satellites are,
It's not. So
B
you
and
looked
C.
at A and B are both correct. So D is
no,
that?
no, the right answer is D.
D,
D.
both B and C.
Yeah,
Yeah. So everybody understand D is the correct answer. D is in dog, number 4. Okay, good. Where were we? Ann Brink, I think. Was I calling on you, or did I get confused here? Ann, polar orbiting weather satellites. I hear Ann. And I think Ann said she was going to be late. Arcia, number 5, polar orbiting weather satellites.
Let's see. B. Our sun's synchronous.
Correct. Yeah, you know, somebody had a question about this one. So weather satellites are B, but the correct answer to the question is both B and C. So it's D as in dog. Has everybody got that?
Yes.
Okay, good.
Which one are you talking about? You're talking about 4 now?
Back to 4, yeah. Somebody
Okay,
just sent me a question about that. I want to make sure everybody got that. Good. Very good. Bill Vahey, number 6. NOAA uses the following polar orbiting satellites. You there, Bill? No. Chris Strawman, number 6. NOAA uses the following polar orbiting satellites.
Would that be C Charlie, METOP, DMSP, and NOAA?
Good. Everybody get that? That is correct. Don Broughton, number 7. NOAA uses the following geostationary satellites.
GEOS and Meteosat.
Yeah, it looks just like it sounds. They say GOES. For the meteorologists, it's the GOES satellites and METOP. Good. Good job. Deb Salvi, number 8. The NEXRAD Doppler weather radar was developed by?
C. DOD, is it DOT and DOC, DOC.
Good. Department of Commerce. Good. Gary Cahill, NEXRAD Doppler radars can detect. You there, Gary? Harold Schlahan, are you here? Number 9. NEXRAD Doppler radars can detect.
D as in Delta, not dog. All of the above.
Roger, correct. Jane Bickle, I have to forgive me, guys. I just don't know who all is here and on the phone here at the same time. 10. The GOES satellite produces images in the following wave bands.
B, visible, infrared, and water vapor.
Correct. B is in Bravo. Well done, Jane. Jason Pfeffer, I'm not sure if you're here. Let's hope you are. Number 11. The primary GOES satellites are located at longitudes. You with us, Jason? How about Jeff Silberg? Jeff?
Charlie.
That's correct. No.
75 West, 135.
Oh, I'm sorry. Yes, I was the wrong problem. That's correct. So you notice both of these have west because they're both over, they're for the GOES satellites, that's for United States. So both of them have west there. You see 175 west off the east coast and one's a 135 west off the west coast. So good, yeah. Jessica McAllister, number 12. Cloud temperatures are measured by weather satellites in the
B, infrared bands.
Excellent, good.
Hey, Bob, this is Jason Pfeffer. I am here. I couldn't get off mute in time.
All right, Jason, number 13. The visible band on weather satellites operates on?
Reflected light, A.
Good, reflected light. 13 is A. Jim Davey, number 14. The water vapor band on weather satellites measures moisture.
Letter C, over the entire depth of the atmosphere.
Very good. John, I don't think John Puskar is going to be here tonight. John Vondra, number 15. The upper air analysis charts are produced?
Charlie, twice a day.
Twice a day, good. Next one is Kevin. Are you here, Kevin? Number 16. Are you driving? Don't do it if you're driving. Okay. 16. Persistence forecasting is useful for?
Bravo. Areas where the weather does not change much.
Good. Yeah. Phoenix, they probably do a lot of persistence forecasting. 120, 120, 120. We lived out there. It was hot. Larry Lindbergh, number 17. Trend forecasting is useful for?
Charlie. Forecasting the position of a tornado.
Good. Good job. Brian Hinton, 18, analog forecasting is mostly useful for?
C, correcting numeral forecast.
Good. Number 19, Linda Coppell, numerical forecasting makes use of?
Both A and B.
Right, not C, not chaos theory. That's random nonsense. Good. D is correct. Good job. Mario Roldan, number 20, ensemble forecasting is? Trick question. You there, Mario?
Yes. I think it's none of above.
Correct. D is the accurate answer. D is in Delta. Ann Brink, you had a question? Go ahead.
Not a question, just I came on right when you were calling my name and I was having problems with the mute button. Just wanted to let you know I'm here.
All right, number 21, Ann. Smartphones can be used to obtain?
It's going to be D, all of the above.
That's correct. They didn't list high cell phone bills in there, but that would have been a good answer too for that question. All right, where are we? Stop sharing.
That's only if you're in cell phone range, though.
What's that?
That's only if you're in cell phone range.
Yeah, don't have to pay. Before we take a quick break here, John, did you want to say hello? You can unmute yourself. Where are you there, John?
Yeah, hello everyone. Can you hear me? Yep. Hey, I just wanted to let people know that for their calendars that July 25th through the 31st is going to be the Experimental Aircraft Association week in Oshkosh, EAA. And the auxiliary runs a booth on the EAA grounds, but our division over here will run surface operations that entire week on Lake Winnebago, and we also run a comm center there. So if anybody is interested, we'd love to have some people come over and volunteer to help us run the comm shack, be crew. If you're TCO qualified, be a watchstander, and coxswains, and even facilities if they're trailerable and want to bring them over. For those of you who know Jen Austin, she's been coming the last couple of years. She'll let you in on the inside stories and all the fun that we have. It's a really great opportunity to get some time on the water, especially after we haven't had much time on the water this last year. This would be an opportunity. So if you have questions and you want to get more information, you can certainly let me know. And the person that is going to be handling all the scheduling and for volunteers and registration is a person named Barb Furman in our flotilla over here in Neenah, Menasha, Wisconsin. And there'll be more on this when it comes time for the D train. There'll be a 40-minute spot for someone to talk about it, and there'll be some more information. I don't have information on the PA booth, but traditionally it's been the DSO AV person who has coordinated the volunteers for the booth. And I will throw out this some new information on the booth. They're moving it to a tent in a different area for social distancing. That this year it's going to be air conditioned, which will be nice. And also, I understand that they've raised our level of being available to where they also are going to allow us to have some access to put some videos and messages and stuff on their website. So good things are happening at EAA. And if you have questions and you're interested in coming, having some fun that week, that's the 25th of July. It's on Sunday. It starts, ends on Sunday. And I'll say honestly that the second half of the week is where most of the activity happens. It starts out slow and builds throughout the week. Thanks.
Thanks, John. Yeah, I've gone for many years. Some of these airplanes are new, but some of them are old, and unusual things happen. And it's a good thing that the Coast Guard Auxiliary is there. It was 2018, only 3 years ago. There was an airplane that had a mechanical problem that was taken off out of the seaplane base, and there was a rescue. And our auxiliary group from our auxiliary folks were out there, and they were the first vessel to arrive. They were observing what was going on, and they were able to rescue someone, who was had gone into the water, and their plane sank. And unfortunately, there were a couple other people that were not able to be rescued, but that was an impressive feat on their part to be there quick enough to save somebody. And other years, there have been incidents where they've had a good Coast Guard auxiliary presence. One year they had a seaplane that had some damage. They went out with some pumps and kept it from sinking. So that was another exciting thing. So interesting things happen at the air show. And if you've never been before, we actually have kind of a group that kind of camps together up there. Not everybody's crazy about camping, but I have an air mattress, and so I can survive for a couple days there. But we're going to go ahead and take a break now, and I show about, what do you got there, 8 after. And let's come back, a big break, the biggest break you had of this class at 20 after. So anybody meanwhile have any questions, you can unmute yourselves and turn your cameras back on, but everybody's on break till 20 after.
Yeah, Bob?
Go ahead, Chaz.
I'll just stick in briefly. I've been up to Oshkosh 2 years, and it is indeed a lot of fun. I've done TCO there, and I even did a little patrolling. So it's a good time to be up there, and good fellowship, and good work too.
Yeah, good way to log some surface hours or surface ops for those of you surface ops people. Go ahead, Jeff.
Bob?
Yes, sir.
I took the AUX C class with you, and I noticed that it's not on my AUX data. I know Ruben was in the same class, and it's on his AUX data. I was wondering what might be the reason for that.
You forgot the donation.
Oh, I always have that problem.
Well, there is a bit of a delay. How long ago did you take that test?
I took it, I think it was like the Friday or Saturday, the Friday after the class ended. The Friday after the class ended. So that was just, 2 weeks ago or something like that?
Yeah, I would give it 4 to 6 weeks. What happens is that goes up to National. National sends it to the directorate, and they will eventually put it into your system. But go ahead, hang on to that completion certificate.
Okay, I'll hang on to it forever. Yeah, all right.
Good.
Hey,
Okay, thanks.
Bob.
Go ahead, Pat.
Got a question. Does this course cover the NOAA data buoys? Because I know you can pick it up on a map where you can actually get all the buoys and get their current information. If I remember correctly, because I used to work with the NOAA crew out of Chicago off the 41.
Yeah, did you look in the appendix in the back of the book there?
I didn't see it, so I didn't know if it was something that was an ad, or should be an ad. But Cal Harbor used to spend a lot of time with the NOAA team. We'd go out and take them out to their buoys just to, so they could make sure everything was running right. So,
Bob?
Go ahead, Alex.
On the U.S. Coast Guard app for smartphones, you can check on the NOAA buoys, and it will tell you what the buoy, where the closest buoy is, and what the status is of the water, and some other valuable information.
Excellent. Yeah, when we had Amy teaching these courses, she had, just the most current, because she worked for the National Weather Service. She had links for their website that you could connect to and have just up to the minute, a lot of good information. And we really miss her. It's a shame she's not with us anymore.
Yeah, Bob.
Go ahead, Tom.
I'm Childhouse. I was on the 2011 MAC race in which the people were killed during that incredibly unpredictable storm. And while we were monitoring weather, of course, it happened so quickly, we ended up in the middle of the lake. We're only about 20 kilometers, less than 15 miles behind that boat. And I'm telling you, that was the most unbelievable weather I have ever been on in a 30-foot sailboat. It was at the time, it wasn't really scary because we were fighting to stay alive. But when we finally got through the weather, we all realized how close we came to dying.
I was out there in that storm too, and we were going through the Grays Reef Passage at the time that storm was going on.
It was a pretty incredible time to be on Lake Michigan, and I don't mean that in a good way.
Yeah, Chaz was telling the story about, I think Ted Turner, I think it was Chaz was telling that story, being out on Lake Michigan. And of course, it's, it's a different animal.
Yeah, Bob, he,
That's the best sense either.
well, yeah, he called it the puddle on the Wednesday before the race. And then his boat didn't finish. It got destroyed by the wind and waves. And then when he came back, he was humble enough to say he was wrong. So, but he's never come back. Whoever said that.
That says a lot.
The way I heard it was that during the height of the storm, he turned around and said, I hereby formally take everything disparaging I ever said about Lake Michigan sailors.
I'm telling you, like I said, being on that particular race, and it was my first MAC, I'm telling you, it was an incredible about hour and 50 minutes we spent on that lake.
So, Nick, are you going to do the MAC race this year, Nick, or do you know?
No, I won't. The year that I was out there and did that, we actually did a auxiliary patrol from all the way down in Chicago up to Mackinac Island. Or, well, we really only went to Station St. Ignace.
Who was on the? Well, that's right by Mackinac Island, right? So who else was with? Who was with on the patrol? Do you remember?
Oh, I have to look up names, but it was mostly guys from. They would be a 9 Central, kind of from Southwest Michigan.
Mm-hmm. Oh, you guys are down there by the St. Joe River, St. Joe, right?
That's where most of the guys were, yeah.
Mm-hmm. That's a beautiful harbor there. When I did AUX air patrols, we flew over that, and it was pretty to watch on our way up the lake shore there.
Yeah, it was pretty cool to go down to Chicago and, like drove right out in a car through the marina, right on the side of the Chicago River there, and went out to the little police Coast Guard station right at the end, and that's where we had the boat tied up and loaded up all the food and the crew and headed out.
Yeah, I watched the MAC and going along with all those sailboats, and sort of like a mother hen and a bunch of chicks, because there's the big MAC just kind of staying in the area.
Yeah.
In case anybody gets in trouble.
Yeah.
Yeah, Coast Guard cutter Mackinac.
Yep, we were working with them too. The cool part about going and being on auxiliary patrol is that if we get bored, we can just start the motor up and motor along.
Cheater. That's cheating.
We weren't racing.
I know. I just.
I'm telling you, it's a whole different ball game when you're racing.
I've done the race twice on the Port Huron side.
So yeah, it's an incredible race, and it was my first MAC, and it was interesting.
Michael Zindrick, are you a power boater or a sailor? You there, Mike?
Yeah, I've done both. Down here in Florida, I'm power boating. I've been sailing in the British Virgin Islands and Lake Michigan, and also
that's a haul. That's a good. You get all the way to the British Virgin Islands. That's a haul.
Yeah.
Well, we flew down there and then rented.
Oh, I got you.
Where did you rent in the BVIs? I rented in at the bitter end, and for about 2.5 weeks. It was pretty cool.
Yeah, we went out and we went with a couple of the different. I'm trying to think. We went with Sunsail once, and the other one with the moorings.
We're at the bitter end, and we really enjoyed it. They were first class. My wife had just started sailing at the time, She's gone now, but at that time, her and I was our kind of our first bareboat experience, and it was pretty incredible. And plus, the owners of the resort are from our area here in the south suburbs, so
Oh, no kidding.
a lot of people we actually knew.
The last time I was down there was it was May after Irma and Marie, and the bitter end was a disaster. We went to Anegada, and most of that was leveled, and this was, they were still really, really hurting from the storm. And over by the bitter end, you could see just half the condos and everything were just up on the hill. They were just blown apart. It was incredible.
I actually almost bought one of those. After that, I was kind of glad I didn't. But I mean, like I said, the owners actually live in Flossmoor, which is only about a 5-minute drive from where we live. So they hire a lot of local people. So we knew a lot of the people who worked there. And it was kind of like chartering with family.
Yeah, it's a neat place. I'm looking forward to getting back there.
I'm going to go back there now that my wife is gone, and she kind of she grew to kind of not like being a real enthusiastic sailor. So now that I'm alone, I'm wanting to get back there, but I'm kind of hoping to try to key in with a couple of people who'd like to accompany me.
I went on a trip and took my wife and with another couple, and we went out of Belize, and that's the wrong place to take people sailing for the first time.
Oh yeah,
it's total third world, and there's coral heads everywhere, and it's not well charted. And
well, I turned 73 on Christmas Day, and 3 days later I got my PADI scuba certificate.
We got to Anegada and we were looking to get to the dive shop, and we moored the boat and dinghied ashore and went to the first bar that was right there by the pier and asked the guy where the dive shop was, and he pointed to a slab of concrete, two destroyed buildings down. He says, well, that's where it used to be.
Yeah, well, it was funny when we were in Anegada and we were at snorkeling, because I didn't have my PADI certificate then. And there was a woman in our party who had a very, very brilliant bikini on. And since that time, I've had LASIK eye surgery, but at that time I was practically blind. And all I could see was this bikini bottom in the water. And they all thought I died, because I figured there can't be two bikinis like this in Anegada. And there was, and I followed the wrong bikini and ended up on the wrong beach. And they were looking all over for me, trying to figure out where the hell I went. And I had to crawl through a coral cavern to get back to my beach. Man, does that coral cut you up.
It sure does.
I've been using that same story for years.
What's that?
I said I've been using that story for years.
Oh, I'm telling you, it happened to me, because my wife, she was like so mad. She's like, I thought you died. And, but when I finally got through the cave, and like I said, I was really cut up. I didn't feel bad then, but the next day I got into the, went into the water, and of course, all the salt water and all those little cuts I had, I knew everyone was. I was not a real happy snorkeler. But it was definitely, like I said, and the captain of the snorkeling boat, he was not happy, because, like I say, he thought I died. Although, actually, I do have to say, it was a pretty nice looking bikini, but not worth dying for.
So who's already finished the test? Somebody said they finished the test already.
I finished.
That you, Penny?
Yes.
Well, what can you tell us about the test? Was it about what you expected?
Yeah, I think so. If you really review the questions at the end of each chapter and you understand the answers to those questions, then you'll be fine.
Oh, do you remember how long it took you? It probably didn't take you the whole 2 hours, huh?
No, it did take me over an hour. I mean, it's 50 questions. I mean, so that's, you know, a little over a minute on each one. I mean, you spend most of the time second guessing your answers.
Uh-oh. Where did the picture go? Here it is. Yeah, Ron, thank you for sharing this picture. Pretty, you know, I had a sun pillar today. And this, didn't you say it was a sun pillar, right?
Right, it was a sun pillar.
Yeah, that's pretty impressive. It looks more like a sun martini glass, doesn't it?
Yeah.
But I was trying to take a picture of a sun pillar today for you to share, but I was driving a little fast on the highway, so that was not the time to be trying to get a decent picture. Two bad ideas.
What makes that? Is that a cloud? And with something coming through there?
I think it has something to do with the reflection off the surface. Now you notice that this is there's snow on the roof here. Probably some kind of reflection off the ground into the bottom of those clouds, huh?
The text below has an explanation as to what they thought was going on.
Not a typical sun pillar. Just after sunrise in Providence, Rhode Island. Let's see. Turn this down a little bit so we can read it. Sun pillar, singular columns of light going up from the sun or the cells rare to see and unknown are known to be caused by sunlight reflecting. Ha ha. So yeah, that right. Huh? Or from hexagon-shaped ice disks falling through the Earth's atmosphere. So we had a lot of snow today. All right, that's not what that is. All right, team, you about ready?
Bob?
Yes, go ahead.
The one wind thing that I found that was really good, and I tried to get called up, is called Wind Finder. And it when I just entered wind forecast into the search engine, it popped up as one of the upper choices, and it appeared to be a really good one.
Excellent. All right, here, time to set sail on to Chapter 8. This is preparing for and executing a mission. So it's a relatively short chapter, talks a lot about safety. So, and we're going to probably open it up to, let's see, how many of you are coxswains? Go ahead and say your name when unmute and say you're a coxswain if you're a coxswain. Anybody here coxswains?
Yeah.
Nick's a coxswain. Any other coxswains?
Well, yeah, I'm in arrears.
Who's in arrears?
Mike Haley.
Mike, okay. Anybody else? So what they're hoping for in this is if you guys have anything to share about your experiences, go ahead and hop in here as you see fit. So discussion is the key of getting most out of this chapter. One of the things up here in the Midwest we worry about is the temperature of the water. So here's an overview of the chapter using weather information in mission planning and execution, restrictions to visibility, thunderstorms and lightning, wind and waves, hot weather issues, cold weather issues, cold water immersion, tornadoes and waterspouts, and hurricanes. And I don't think we're allowed to use the warm weather attire up here in the Midwest. I don't remember, even though it gets hot up here sometimes. So if you're going to be planning a mission and you're a coxswain, you're studying the current situation. You start looking 2 or 3 days prior to patrol, you know, or if you're in air ops, you know, you'll be starting to pay attention to the weather forecast coming up, and then you relate it to what you see around you. So if you go outside, you're going to be focused on what the clouds look like. You're going to get familiar with the winds, temperature, and humidity. And when you're getting ready to launch, you're going to focus a lot on the present weather. If it's fog, haze, rain, snow, etc., is that expected to continue? Now for the GAR, we're going to talk a little bit about GAR here shortly, but a lot of those things might present an unsafe situation, which might keep you from leaving the dock. So when you're planning a mission, examine the radar and satellite data. Watch the movement of the precipitation areas. Watch how clouds relate to the current conditions. Examine the local forecast and how consistently have they been over the last 2 or 3 days. Monitor the condition, and then you make the final decision to launch. And that was, I watched some aviation YouTube recordings, and there was one on a young pilot from the upper Midwest, Nebraska, I think it is, Matt Guttmiller, and he departed off a high altitude airport out in the western part of the United States, I think it was Idaho, and he was going on the radar that he could see on his equipment. The problem was the radar coverage is not very good in that part of the country. So he ended up getting into severe turbulence and returning back to the airport he departed from. And it was not a good experience for him because he didn't have that local information. Here it talks about local forecast. Having some local awareness, that's going to make a big difference. What do you need to consider? What about restrictions to visibility, like fog or heavy precipitation? Now, it could be that you have weather radar on board, but in the fog, you need to have a sharp lookout, because what if there's debris in the water out in front of you? What if they don't have an AIS, or there's something with an AIS could give you information, but if it's just something floating around in the water and nobody's watching out the front of the vessel, it's going to be a problem. You have to have a sharp lookout, which is why we talked in auxiliary seamanship about no other duties. Your job is to look out for what's coming in front of you, not to be distracted by other things going on. So things to consider: what if there are thunderstorms and lightning? Is there forecasts of thunderstorms and lightning? What are the winds and sea states? A lot of times earlier, or even around midday, you'll have lower seas, and then as the day goes on, after the winds start to pick up and the seas increase. What are the air temperatures? And we do talk a lot in this chapter about hyperthermia, which being too hot, and hypothermia, being too cold. What does that mean for your GAR score? You have to keep that in check to determine whether or not it's safe to go out on the water. Talk more about restrictions to visibility. Fog and heavy precipitation can reduce visibility to dangerous levels. Radar helps, but you can't see flotsam such as logs because they sit pretty low in the water. If you don't have a chart plotter, you're going to need someone to keep positions and plot those positions on a paper chart. Be sure to carry charts and plotting tools, if nothing else, as a backup, but as part of your mission planning also. If your GPS fails, you will need to know what compass course to steer toward your destination, and have deviation tables for normal operations and for loss of electronics. Electronics can affect the compass. So, and I think it talks about it here shortly, but if you see what heading would take you to the nearest safe harbor, turn the vessel to that heading, and before you have that lightning hit and maybe mess up your GPS, look at your compass and see what, with the drift and the winds, what heading is taking you towards safe harbor. So in case, you have to go off course for a time to deal with the seas, when you lose visibility because of heavy rain showers or fog, going back on what course will return you to the nearest safe harbor. More restrictions of visibility. So other things to do when the visibility goes down: take a compass bearing on your safe haven or destination way you can still see it. Remember to use the proper sound signals. We talked about that in auxiliary seamanship, and it comes up in the Boat America course too. Assign a crew to radar watch or listening watch. That way the helmsman can maintain, or in this case, a helmsman can maintain a visual watch. But sounds, obviously, if you're making sounds to alert other people to your presence, you're going to be wanting to listen to to sounds from other vessels in case you have someone nearby. and reduce speed sufficiently to stop or turn if a collision is imminent. Now, your radar may tell you there's nothing out in front of you, but by going at a higher speed to hurry back to shore, you could putting yourself in an unsafe situation. So you don't want to be picking up your speed to get back to shore in a hurry if it's going to put you in a scenario where if something pops up in the water in front of you, you can't stop, and then you have a problem. So in the worst, if you just went down to 0-0 and it wasn't safe to proceed, you would anchor. Now with the charts, you could tell if you're going to be in a channel, and so don't do so in a channel because someone else passing through that area is liable to be a conflict with you. Keep your controlling station notified. They will likely put you on a shorter reporting schedule, like a 15-minute reporting schedule versus 30 minutes. And that way they can keep close track and how you're doing out there. So we talked a little bit about that in AUXCOM a couple months ago. Here comes some thunderstorms. Well, don't patrol even if there is just a watch. So don't patrol during a severe thunderstorm watch, because the time to be safely on the shore is not when the thunderstorm hits. It's when you said, well, we're not going to be able to do the patrol today, team. Decide the level of risk to take if there are thunderstorms, if thunderstorms are forecast. If you have a regatta or a VIP movement or something like that where you have to have a safety zone, you really have to decide whether or not you have experienced crew, whether or not the vessel is ready, your whole GAR score. So if there's a risk and if it's likely, you probably should not go out. You don't want to make the news by being the vessel that needed to be rescued instead of the rescuer. If there's a slight chance or a chance, you're relatively safe if you keep a sharp lookout for developing storms. And I think we talked a little bit about that in an earlier chapter, where if you see a gust front coming at you, like a splashing of water where there shouldn't be any sign of waves there, that could be an indication that a thunderstorm is imminent. Air mass thunderstorms can develop quickly and are the hardest to plan for. You're going to see that again. It's those air mass thunderstorms. They're not in a line. They just develop naturally from the instability of one cell. Now, if you decide that it is safe enough to patrol, stay current with developments. And Chaz hit this pretty good earlier in terms of listen to your weather radar. Notice what the other vessels around you are doing. If they're turning back to shore, maybe they've got a good sense that something's about to hit. You can use your smartphone radar apps to help keep track of storms. Your VHF weather channels are of some help, but it doesn't. Just because you're tuning into the weather radar doesn't mean you look at the ground. You are scanning the horizon. Keep a weather eye. Get a weather update from your controlling station. Have a friend or family member monitor the weather and call you if thunderstorms are approaching your patrol area. Sometimes we can see the weather from a far distance away. Other times we got weather coming at us, and because of haze or restricted visibility, high humidity maybe, we may not see it until it's pretty close. More about thunderstorms. If you can't avoid a thunderstorm, take the following action. Determine what your course would be to a safe harbor. Brief your crew and contact a controlling station. Stow all loose gear. You don't want to be tripping over the deck when those waves start to hit because you didn't put away a line or something else that could have been stowed. Note the wind direction, and that can tell you how close the storm is. And watch the water for ripples that mean a downdraft is coming or a microburst. Move perpendicular to storm movement. So if you can see a very slow moving storm and it's fairly small, then move to a 90-degree angle, one direction or another, if you can, safely in the time that you have. So when the storm gets close, turn into that gust front so you can maintain control of the vessel. If there's lightning or thunder, turn off your electronics on the vessel and lower the antenna. Stay away from metal objects. And you can communicate via cell phone if possible, but with those radios, that they, if you have somebody next to the radio and that antenna gets hit by a bolt of lightning, not only is the equipment going to be damaged, but someone might be hurt. Wind and waves. Small craft advisory issued under conditions that vary by the region. So other regions like Florida has specific rules. Here in the Chicago area, we have different rules. Up in Upper Peninsula, Michigan, they have different rules. So whatever the local area is, find out what qualifies as a small craft advisory. A friend of mine often said at this point that anytime you have a small craft advisory, that's not going to be a good day out on the water. So that's got to be part of your planning. If you know that there is a small craft advisory, it better be a high return on that mission if you're actually going to go out on the water. This one, though, is standard. A gale warning is issued for winds of 34 to 47 knots. 34 to 47 knots. The wind wave height is determined by the sustained wind speed, the duration of wind, and fetch. Now, fetch is the distance over water that the wind blows. And for those of you that are familiar with Lake Michigan, if the winds are out of the northeast, they go down a long stretch of Lake Michigan, and there's nothing to slow those waves down. So that's when we can have shoreline flooding here in the Chicago area in northern Indiana there, because all that distance, the wind has pushed and pushed and pushed those waves, and so the wave heights can be pretty big if they have a high fetch. Now, if the winds are out of the east or out of the west, if you're in western Michigan, I used to live in western Michigan, if you get westerly winds, you will have some waves on the western part of Michigan if the winds are coming out of the west and they get to blow over that distance of Lake Michigan. But it's much stronger if they have a large fetch, like they're blowing from the northeast, northeast to the southwest. The period is also influenced by the average water depth. That's one of the things that makes Lake Michigan pretty dicey is water in some places is not very deep, so you get those short periods, bam, bam, bam. The wave tops are coming very quickly one after another, and it can be an uncomfortable day to sail. So the steepest waves are when the wind blows against the current. One of my friends here on the auxiliary served up by Cape Disappointment, which is at the mouth of the Columbia River up in the northwestern part of the United States. And there, when the river current is coming down and the wind is blowing in from the west, he said large commercial vessels that got caught in those rolling breakers just got turned into matchsticks, because it's just like being in a hamburger grinder, just ground them to pieces. So when you have the wind blowing against the current, you can get some very steep waves, and you can have a danger of broaching or pitch pulling. For planning, you can often use nearby data buoys, and someone brought up the way to find that on that website, which is great. And somebody brought up the question of data buoys, and that was a good question. Wave forecasts are given as a range of heights. So from 3 to 5 feet, this range covers the most likely heights, but some of the wave tops are going to be higher, and some will be lower. So if you have a wave forecast, remember that you occasionally could have one that is higher than what they're forecasting. Warm weather issues. Right now, with 18 inches of snow on the ground here, I dream of warm weather issues, but come summertime, come the Oshkosh Air Show, you have to be ready for perspiring. And the body cools by perspiring, and that causes evaporation from your skin. It cools it. So the higher humidity, the slower that sweat evaporates. And so you can be more and more uncomfortable the higher the humidity. Overheating can lead to heat exhaustion or even heat stroke. The danger of overheating can be estimated by knowing the heat index, which, they're going to show the graph here in a second, but it considers both the air temperature and humidity. And you notice that it doesn't show as high when you have low humidity or low temperature. It's that combination of the two the heat index can be really a dangerous thing. The heat index is not exact, but it does not consider age, weight, clothing, or health. But that warm weather issue there of the heat index is a good relative indicator. Obviously, some people like me that probably need to be a few pounds lighter, it's going to probably hurt people like me more. So an example of a heat index chart from the American Meteorological Society, here it is right here. And you notice right in the center here, this is the rough zone when you get relatively higher humidity and relatively high air temperature. Get your air temperature up here, and you get your humidity up here. It gets here, you don't even have to have that high of an air temperature for it to be dangerous. Even if, I guess 95 is fun to dream about 95 right now, but in the temperature, you know, above 90, around 95, even if the humidity, I mean, even if the air temperature is only 95, you get these high humidities like you folks down in District 7 fight with all the time, come the hot time of the year, then that can be very dangerous. So the relative, the heat index showing up here in the red at 136. So 130 or higher means extreme danger, and it's a good potential for heat stroke unless you're just out for a very short time. Down here in the yellow, your body with a certain amount of heat and a certain amount of humidity will tire out more quickly. And that's another thing you have to keep in mind when you're out there on a patrol, how long you are going to be out there, because you may want to rotate people around to different jobs just to try to keep fresh, but it can be much more fatiguing. Now let's talk about cold weather issues. If you have still air, your body warms a shallow layer known as a boundary layer right next to your skin, both underclothing and bare skin. If it starts to get windy, up here like it has been the last few weeks, increasing wind speeds remove this protective layer, increasing the rate of heat loss. So that can cool you off. The rate at which exposed parts of your body lose heat depends on the temperature and the wind speed. You're going to see that again. So if it's you got a combination of real cold and it's pretty windy, you're going to lose a lot of heat fast. So that's a danger. Heat loss increases with reduced temperature. Heat loss increases with increased wind speed up to a point. They make up an effective temperature called wind chill. And the following slide will show you that wind chill temperature table. So let's see, what temperature was it when I was out delivering groceries? It was about -3. And let's see, the wind was about 20 knots. Pretty sure the speed is in knots. So it was a bitter day to be out and about. And we've had a fair amount of this lately. But even here with the temperature above 0, you know, if the winds really start to blow, you know, here it is, it's 5 above. The winds are blowing at 30 knots. When I was out walking around that airplane doing a pre-flight check, and I was so cold, I put my glasses, I don't know where my glasses are, I put them down, and I was not comfortable. I haven't found my glasses yet, so these are my backups. So that's a little comparison of the wind chill temperatures here. And obviously the colder, the windier, the more deadly. Tornadoes, waterspouts, and hurricanes. So the National advises us not to patrol during a tornado watch or a severe thunderstorm watch. It seems like pretty good advice. And obviously, even if it's just a watch, the time to make those safe decisions are before those hit. So if you encounter a waterspout, travel in a direction perpendicular to its movement. Now, it's not as dangerous and deadly as those tornadoes, but you could still, you know, someone could be injured or knocked off the side of the boat, and that would be a bad day. Do not patrol during a hurricane watch or warning. And remember the times between the watch and the warning. So that's within 36 to 48 hours of landfall. Prepare your facility, including topping off fuel, to be ready for an ATON or search and rescue patrol after the hurricane. So you're like, well, there's a hurricane coming, we're not going to be doing a patrol. That doesn't mean it's not a good idea to have the vessel ready to go in case some mariners are in distress and you need to respond. So, of course, you're probably aware of the dangers involved, and so it's hard to keep that in the back of your mind, but preparing beforehand, you know, saves time later on. Protect your facility in whatever way is appropriate in your area. And, you know, for a lot of people, if they have a, what are those winches called that gets the boat out of the water? Nick, who's down in Florida? Who is that again down in Florida? Rodney? What are those called when you get your vessel out of the water? You there, Rodney?
Travelogues.
What is it?
Travelogues.
I don't know why I can't hear you. Yeah, but getting it out of the water.
Yeah.
protect your facility in whatever way is appropriate in your area. And discuss these with the class for individual actions in our AOR. We don't get too many hurricanes in this area, but if there was going to be a severe thunderstorm watch, you got electronics on the boat, you know, getting the, Nick, did you guys, they're in Southwest Michigan, do you take the boats out of the water if there's a severe thunderstorm watch?
I don't think anybody's pulling a boat out for that, no. That's expensive.
Yeah. Good. Thanks, guys. So, a summary of Chapter 8. Know how to use weather data to plan for patrols. Consider the following in planning and know how to deal with them while on patrol. Reduce visibility. We talked about heading to shore if you can, or get a compass heading when you can. Thunderstorms and lightning. You know, have your crew avoid being around some of the metal objects or holding on to metal objects if it's possible for them to safely do that on the boat. Wind and waves, you know, keeping everybody from moving in the boat just like you normally would when underway. Warm and cold weather dangers. You know, if you have somebody that, one of the things the book talks about is if it's cold, you're trying to protect yourself, but if you only open the back of the rain cover, then the exhaust that would normally go out of the back of the boat could be sucked back into that exhaust cover, and then it's like a shell with the only opening is where the exhaust is going to come into it, and that could be a danger in cold weather. Cold water dangers. Water will wick the heat away from your body much quicker than the air will. Even though the air can make you cold, the water is going to steal that heat energy very quickly, and that's why there's a lot of restrictions here on Lake Michigan, why we don't do patrols until late in the season. Even though it's nice and warm outside, that water temperature is still cold, and if we had a man overboard, that person could be injured. And we talked about water spouts. So weather is just one aspect of risk reduction, but it can be very important part under some circumstances. So keep a weather eye out and you know what direction to look for your next storm. All right, if you will all forgive me, I'm going to go ahead and find the questions here. All right, let me see if I can figure out where I ended up for the last questions. There's not a lot for this chapter, so this is going to go kind of quick. We're doing really good on time. Let's see. Patrick, did I ask you a question? No. Whose turn is it? Patrick, Patrick Dugan, did you get to answer a question last time or not?
No.
Patrick, number 1, what steps are included in using weather for planning a patrol?
D, all the above.
Good. Excellent. Are you crew qualified, Pat?
No.
Patrick Leonardi, number 2, while on patrol, visibility becomes restricted. What steps should you take?
D as in dose. A, which is A and B. You take a compass bearing for safe harbor, and then slow down.
All right,
take it
Pat.
slow as pro.
That's correct. Number C there, Patrick. Why is C wrong?
Because they're already supposed to be on watch.
Right. Well, what they're hinting at there is maybe have somebody on the radar watch too. So if you put everybody on visual lookout,
but somebody should be on the radar. That's considered part of your watch. If you're not watching the radar, you're not following the rules according to what I learned.
Good. So that's why D is correct. Good. Paul Luna, number 3. With regard to thunderstorms, which kind is the most difficult to deal with in the planning phase? You there, Paul? Paul Luna? Maybe not here. Paula Wicks. With regard to thunderstorms, which kind is the most difficult to deal with in the planning phase?
The air mass thunderstorm, C.
Why isn't it A or B? Do you remember this one?
Because the The air mass can come up suddenly.
Yeah, usually a frontal system or even a squall line will be in a larger area and you can see them coming, but air mass thunderstorms just pop up out of nowhere. Penny Ross, you took the exam. We're skipping you. I'm sorry. Congratulations on passing, Penny. Peter Lemire, number 4. When a thunderstorm is approaching, you should initially... You hear, Pete? Bill Leonard, when a thunderstorm is approaching, you should initially...
B Bravo, run perpendicular to the direction of the storm movement.
Right. Yeah. Initially, it's close enough that you can see it, and you know it's going to be a problem for you, but it's not too close that you don't even have a chance to run away from it a little bit. Good. Phil, let's see. Rodney Jansen, number 5. What evidence should you watch for that says the effects of a thunderstorm are imminent? You there, Rodney? Take a stab at this one. Ron Briscoe, what evidence should you watch for that says the effects of a thunderstorm are imminent?
That would be A, ripples on the water.
Right. You know, the first time I looked at that, I was like, well, these two could be a sign too, but what they're getting at here is it is on you. You know, if you start to hear static on a VHF radio, do you even have static on a VHF radio? That's an AM radio I'm thinking of, huh? So you're correct. It's A. Reuben Howard, number 6. Small craft advisories are issued under what circumstances? Trick question. You there, Reuben? We had trouble with his mic before, didn't we? You there, Reuben? Sean, did you say you were here? He said he was going to be late. Sylvia Tipsord. Small craft advisories are issued under what circumstances?
D, it varies with the region of the country.
Excellent, that is correct. Thomas Schildhouse, number 7. A gale warning is issued when winds are expected to be?
B.
C is correct. Thank you, Thomas. Kenneth Yansky, number 8. The heat index is a function of? You there, Kenneth?
It's temperature and relative humidity.
Good. C, right? Good.
Right, C.
Correct. Farron, are you here? I'm sure she's coming tonight. You here with us, Farron? Adam, back to you. Wind chill is a function of?
It would be B, temperature and wind speed.
Who was it? Was that Adam? Oh, that was Adam. Okay. Alex Carmichael, number 10. The effects of heat exhaustion and heat stroke increase with?
C, increasing temperature and increasing humidity.
Correct. Good job. Is Amanda McAllister here? You home? Number 11. The possibility of hypothermia increases with?
Decreasing temperature and increasing wind speed. A.
Good. All right. Any questions on Chapter 8? It's fairly short. The book has more detail. Dry suits, it talks a little bit about Mustangs. Yeah, I don't know if you guys in Florida, maybe you do get Mustangs, huh?
They do issue us float coats.
Yeah, well, my friend, let's see, 2 people raised their hand. So let me see it. See if I can figure out who did it. Who's one person that raised their hand? I can't see who raised their hands because it's a long list. Did somebody raise their hand? 3 participants raised their hand. Oh, now I'm confused. I'm going to go ahead and stop sharing so we can see who that is. Arcia, go ahead.
You know, Bob, I actually did that on accident.
Oh, okay.
Sorry.
Who else is here? Anybody else had a question? Ann Brink. You there, Ann?
I'm here. I'm just wondering why it's showing that I'm raising my hand because I only did it when I joined the meeting, and now it's just stayed there for whatever reason.
Well, as long as all the fingers are up, I'm okay with it. Let me see if I can show you. Well, that I was just teasing. Sorry.
I think when you raise your hand, it stays there until Bob acknowledges it, in case people have questions.
Correct. Although Arcia figured out how to get his to go down. All right.
Yeah, I tested mine, and I think it's gone now, so you shouldn't be seeing it now.
All righty. Who has not ever taken a test on the National Testing Center?
I have not.
That would be me.
All right, team. For those of you that have already seen this, this is going to be a replay. And so bear with me because you might find this very boring. Let's see, where's that? We'll leave that up. Okay. So I need to share my screen if I'm going to show you anything, right? All right, where are you here? Share screen. All right, here we go. So you go to, you could just Google, I think everybody uses Google, right? Auxiliary National Testing Center. So easy, there's another way to do it. I'm going to show you this way. It's just as easy and everybody knows how to use Google. Auxiliary National Testing Center, boom. First thing that pops up, National Testing Center. For people that are brand new, Adam, you probably won't be able to do this because you don't have a number yet. But for everybody else, it will take you to the new National Testing Center. And over here is Take a Test. You left click on Take a Test. Go ahead and enter my information. And that gets me onto, you have to have your password and your member number. Over here on the left side of the National Testing Center will be all the tests. And you scroll down, 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 down. Believe it or not, W at the end of the alphabet is all the way at the bottom. So you got to know to scroll down. Left click on that auxiliary weather test. Boom. It tells you everything you need to know, and you are ready to start your test. Somebody else also passed their test besides Penny. Who was that? One other person. They probably didn't show tonight because they had a flotilla meeting. But as we highlighted a lot in the class, and Penny also shared with us, go over those review questions. You are welcome to come to the Sunday review session, but with the information that you have and the fact that it is, where is it here? Open book. Where's the sign here that says open book? It's an open book test. You can have your textbook, you know, in front of your student study guide with you, any notes that you've made. There are 50 questions. And Larry Lindbergh, what score, how many questions would you have to get right out of 50 to get a 90%?
40.
40 questions, right? So you can miss 40. You can miss, no, 45, right?
45.
Oh, you were trying to see if I was paying attention. No, 45. Back to the class, Larry, sorry. So you do get 120 minutes. For most of you, it's not going to take 120 minutes. Test taking strategy. If you get one question that just stumps you, don't let that throw you off the game. And so, you know, just go on to the next question, shake it off. Somebody had a question for me. Who was that? Chat. Oh, I can't open it right now for some reason. Does somebody have a question? Go ahead, pipe up.
Oh, I have a question, Bob. It's Anita Lucas.
Go ahead, Anita.
There's a lot of information on the slides and questions that are not in the textbook. So will the test only be regarding the information that's in the downloaded file, or
yes,
will these slides which have additional information be included in the test?
No. Does everybody know how to go see the slides? Here's a good one. All of you, I assume, have your auxiliary directory. You all have your auxiliary directory passwords, don't you, except for Adam? All right. So what you go, if you want to see the slides yourself, cgaux.org. You're going to be here, and you're going to go to directorates. Down here is training. Click on training. Then you want to go over here on the left. It says AUX courses. Go down here to AUX weather. And then you, you want to navigate to the auxiliary classroom. So you see this hot button here? Can you tell that's ready to be clicked on? Left click on that, and you will need to enter your username and your password. Now, if you've forgotten your username or password, you just enter your email and it sends it to you. But in my case, I told my computer to save mine, and so it's right there, and then I hit log in. And after it logs in, it goes to the auxiliary weather page here in the classroom, and you'll go down here to look at downloadable PowerPoint files. Now these are big files, and you do not need to download them to look at them. I just left click on that, and look, it shows all 8 chapters here. And you don't need to memorize all those numbers from those charts. There's a lot of the questions that they have in the practice questions that give you a lot of good information. But you just left click. You see how these are underlined here? You can click on those and you can see the entire slideshow if you want to do that for reviewing. Now, more test taking strategy. To take the test, there is no penalty to take it right now. You could, as soon as we all log off here, you could take that test right now and it won't curse you. Nothing bad will happen. It'll tell you what you got. Now the testing web page has been a little glitchy. So it is supposed to tell you the answers that you got wrong, which really helps you. So one other thing I wanted to share, which is, let's see, close a few of these. One of the things I wanted to share, which is the Como Mic website. For those of you that have never used this before, it's comomic.info. I'm going to send you this link. Don't worry, you'll get it from me, and when I send out the recording of tonight's program, you'll be able to see it. And with that, I'm going to stop recording here. Where is it here? No, where's the recording? All right, I might have already done that by mistake. Oh well. Over here on the left, you see the names of all the tests that you can take. If you left click on the name of the test, not next to it, this will just show you the textbook. But on the green button itself, if you left click, it will open practice questions. comomic.info. Now here it says, steady winds tend to blow parallel to the isobars when the effects of blank and blank are negligible. So parallel to the isobars.
Am I reading that correctly? There's 505 questions.
This is every possible question on the test. The thing about it is, if you go on Como Mic, take 20 practice questions, you'll have a hint whether or not you're going to be able to pass that test the first time. Let's say you take it once or the test for practice or whatever, once or twice, and you're struggling a little bit. You can go start going through these questions, and it'll tell you right away if you've got the right answer. So let's see. Steady winds tend to blow parallel to the isobars when the effects of blank and blank are negligible. So let's say we were going to say friction and Coriolis. So notice it's wrong. Now we go to the right answer, oops, which is local rotation and friction. You can tell I didn't practice this one in advance. And it tells you the right answer. So now you want to try another question. Where's the button? This is next question. See down here, another question? You click on it, and it'll give you another try. Winds affected by friction blow. You can tell I'm not ready to take the test right now. At right angles to the isobars, no. Across the isobars from high to low pressure. So it's going to go from high to low there. I'm not going to get a 90 on this one. Assuming all other things equal, the highest wind speed should be expected where the isobars form a ridge. Tell somebody needs to practice their questions here. This is a good way to do it. comomike.info. Questions. I'm going to go ahead and stop sharing. Anybody got a question?